All right, students. So today we're going to talk about areas of bounded regions, but this time they're going to be broken up into multiple bounded regions. So first what you're going to need is some graph paper. You're going to need your notes from the other day. We're going to complete them. And some different color pens and highlighters, okay? So the first example that we're going to do, you want to draw an X and Y axis first. And we want to find the area bounded by these curves, y equal to x and y equal to x minus 2 being squared on the interval of x equal to 0 and x equal to 3. So our interval of 0 to 3. So first, let's go ahead and start graphing this. So y equal to x is very easy. We have our line, y equal to x line. Like so. And I'm going to label this y equal to x. And then our parabola, which is shifted to the right 2 units. So here's the vertex at x equal to 2. And then I am going to put in the points. As you go right 1, you go up 1. You go left 1, you go up 1. You go right 2, then you will go up 4. And you go to the left of your vertex 2, and you'll go up 4 as well. And there is our parabola. Y is equal to x minus 2 being squared. Okay? And we're looking at the interval of 0 to 3. So here is 0 and 1, 2, 3. So we're looking at that interval. That is another way of saying these lines right here. Okay? So I'm going to go ahead and highlight with some colors the curves that we've just drawn. And now we want to figure out what bounded region are they talking about that is on the interval 0 to 3. So might help to draw in x equal to 0 and x equal to 3. When you look at that, and you look at this right here, you'll see that it's broken up into multiple regions. Okay? Now, the two curves intersect at this point. So one region is this. It's bounded by these two and actually x equal to 0. And the other region is this right here. From this point on to x equal to 3. So we have two regions that we need to find the area of. But actually, when we're finding the bounded, we're going to take both of these and we want to add them together. So the total area of the bounded region will be A1 plus A2. Area 1 plus area 2. I'm going to call this right here area 1, and I'm going to call this right here area 2. So the next thing is that we want to look at some rectangles. So we know that we're going to draw a couple of rectangles throughout. But as we draw this, pay attention to the colors that we're touching here. When I go upper minus lower on this region here, I'm doing the orange minus the blue. Here, when I get to over here, I'm doing the blue minus the orange. So once we cross this point of intersection, all of a sudden things get flipped. So their upper and their lower functions end up being different once you cross their point of intersection. So area 1 and area 2 are going to be two different integrals. So let's first write down what the integral is for area 1. So area 1 goes from x equal to 0, and we draw rectangles all the way up to x equal to 1. So 0 to 1, our interval of 0 to 1. And then we look at our upper function. Our upper function is the orange one, which I have here as x minus 2 being squared. That is our upper function, minus the lower function, which is y equal to x, so minus x. And then we'll do brackets, dx. That is area 1. Now, area 2. Area 2 is a different integral because when you subtract upper minus lower, the functions are different. So the upper function in this situation is going to be x, and the lower function is going to be x minus 2 being squared. Dx. And now we need to also discuss the limits of integration. So here is 1, and we're looking at this area. We would draw rectangles from 1 all the way up to 3. So x equal to 1 to 3. This is what the total area is equivalent to. That is the integral expression for this area. So you have to pay attention. Just make sure that when it crosses a point of intersection, check to see if the upper and lower function ended up switching. Okay? Now, the next